Hi there, I'm Thomas and I've just finished my third year of an astrophysics degree at the University of St Andrews. This has been an odd year. It's been my third year of university and it's been academic year 2020 to 2021, which I'm sure I don't need to tell you has been the COVID year. About a year to year and a half ago, COVID-19 reared its ugly head. The world went into lockdown and universities had to change quite a bit. But I'm not going to talk about COVID that much in this video. That's going to be coming in a future video where I'm going to be talking about universities and coronavirus, the pandemic, everything, and revisiting a video I did about a year ago about whether universities should be going back to normal. That's coming later. Make sure you subscribe and hit the bell icon so you don't miss that. This video is a review of my third year in physics and astronomy, specifically astrophysics, at the University of St Andrews. It's going to be a fairly in-depth look at the last year from an academic point of view, from a social point of view, from a personal point of view, looking at how I've changed over the last year. I'm going to go one semester at a time. I'm then going to talk a bit about the full year and then finish with just a bit about, well, everything. But before I talk about those semesters, let's just have a quick look back to where I was at the start of the year. So August-ish 2020. The pandemic had been going on for five months. I swear I'm going to stop talking about this pandemic soon, but it's important. The pandemic had been going on for 5 months at this point, and I was supposed to be going back into university halls of residence, specifically University Hall, where I'd lived for 2 years at that point. But I wasn't convinced it was going to be, well, safe. The thing is, I am asthmatic. I have exercise-induced asthma, which puts me at a bit of a higher risk from coronavirus. Not enough to get me in the priority groups for the vaccine, but enough to make me concerned about getting it. So I made the decision to try and find a flat to live in. This was a month before university was going to be starting up again, and I had really got nowhere to live. So I got into this sort of idea of I need to find a flat, and I did find one. 3 weeks before moving in. It was the first time I was going to be living out of university halls, so the first time actually properly living independently. I had a flatmate that was moving in with me, but it was the first time I was living without parents and without university wardens to help if something went wrong. And that was a bit scary, but ultimately pretty good. I was also in a fairly rough position. I'd had some stuff had gone on over the summer that I'm not going to talk about online. I don't feel comfortable talking about online yet. I don't know if I ever will, but it was a bit of a tough time personally at that point as well. So it was going to be a bit of a tough start to the semester, given we're under restrictions and I wasn't able to see a lot of my friends in the same way that I was able to in the past. But I wasn't going to let any of that stuff stop me. I was there to get a degree, and I love St Andrews, I love physics and astronomy, so that wasn't going to stop me. Something that my friends and family will tell you is that I can be quite stubborn, persistent. I'm going with persistent, they might go with stubborn, but anyway. This brings us on to semester one. Semester one of third year. This is a year that is widely regarded as the worst year of the physics degree at St Andrews, the hardest year. One of the most fun, but also one of the hardest. It's the one that makes people really question if they should be doing the degree, but it is, in hindsight, a really good year. So let's look at first semester, and I'm going to start off with the bit that kind of makes sense, doing a review of the year, which is the academics. In the first semester on the astrophysics track, you will do 4 modules and I guess half of another one. So there are 3 of those modules that are required for everybody doing junior honours, that's third year physics at St Andrews. Those are Maths for Physicists, Quantum Mechanics 1, and Computational Physics. There's a 4th module that I take because I'm on the Astro track. Now, it's not required to do in this year, but most people do, and that's called Extragalactic Astronomy. The other module that you kind of do half of, because it's a full year module, is Transferable Skills for Physicists, which I will talk about at the end after I've talked about each semester individually, because it's a full year module. So, these modules that I took, Maths for Physicists, Quantum Mechanics 1, Computational Physics, and Extragalactic Astronomy. Let's start with the one that I found to be the most enjoyable, which was Extragalactic Astronomy. Shock horror, the astrophysicist likes the Astro module. This module is one that I found to be really interesting because it covers quite a wide array of things to do with extragalactic astronomy. It also touches on cosmology quite a bit as well. So we look at observing galaxies, we look at why some galaxies are spirals while others are elliptical. We look at ones that don't fit into either category really, or kind of fit into both. There are so many different interesting parts of the course. We also looking at the sort of models of the universe, cosmology, and why the universe is the way it is. How the fact that if gravity was that little bit stronger, the entire universe would have crushed back down, or if it was a little bit weaker, that the entire universe would have kind of ripped itself apart. It's kind of elegant how we've managed to explain it all, but there are still all these massive questions. It's one of these really evolving areas of research. Something that was actually mentioned in some of the lectures was, this is our current best understanding, but we don't know. Extragalactic astronomy is something that is going to get a massive boost, hopefully next year, because the James Webb Space Telescope is hopefully launching on Halloween this year, subject to the Ariane 5 rocket, the whims of about every single deity in the world, I guess, at this point. Goodness knows how long it's been delayed for. A better part of a decade, I think. I will believe that thing launches when it launches. I'm getting off top. This module is kind of everything that I would ask for in a module in terms of its content and makeup. So extragalactic astronomy is not my favourite area of astro. I much prefer stars, stellar evolution, that sort of thing. But I do find it interesting. But the way the module was set up was kind of perfect in my experience. The module was made up of a decent number of lectures, some larger tutorials. In fact, it was an entire module tutorial. We got lumped into a socially distanced lecture theatre and just got to essentially ask questions and go through things with the lecturer as an entire class. Something that was, I think I didn't appreciate at the time, because, like I said, we were under COVID restrictions. We didn't really get that same sort of get everyone in a room and do physics. And we got it in that module, and I don't think I appreciated it at the time. On top of that, we also had a computational project. This was something we worked on for most of the year, most of the semester. And it was using data, actual data from the Sloan Digital Sky Survey, looking at numbers of galaxies in a population based on colour, and this apparent green valley, as they call it. So most galaxies that we see are either red, these elliptical old galaxies, or blue, these young dusty galaxies full of loads of young stars, like our one. And then there's these ones in the middle that don't really exist. There's this massive gap between the populations of these galaxies that aren't really red and they're not really blue. They're not young, but they're not really old. They should be these sort of intermediate age galaxies that we just don't really see. It's kind of the same way that we don't see stars in this gap in the Hertzsprung-Russell diagram between the young stars and between the older dying stars. There's this big gap, and it's really interesting. And we got to deal with actual data using Python, using a programming language to computationally analyze the data and start trying to draw our own conclusions from it. And I really enjoyed it. It was a part of the module that felt a lot more like doing actual science. And that's something I got a kick out of doing science, of learning, of investigating, of researching. And it was a great module for that. It's really a module that I think I didn't appreciate at the time. It was taught really well, and I think it leads on well to other parts of the course. Next year there's a module called Observational Astronomy, or Observational Astrophysics? I'm not sure. Obs Astro is what we call it. And I'm probably going to be taking that module, but I don't know. And it's something that I think leads on well to it, because that module has quite a lot of data analysis in it as well, as far as I know. And while this might be as far as I go with extragalactic astronomy, I'm glad I did this module. I'm glad I had to do this module. But I did a load of other modules in this first semester as well, so I should probably talk about them. So, moving on, quantum mechanics. Quantum mechanics is kind of the opposite of extragalactic astronomy. Extragalactic astronomy looks at massive things on the scale of the universe, whereas quantum mechanics looks at things far too small to even see. It's everything on the really small scales, your atoms, your electrons, that sort of thing. And it's the first real look into quantum mechanics that we get into how we explain quantum phenomena. We're taught a little bit of quantum physics and quantum phenomena in the sub-honours years, so the first couple of years at St Andrews. The thing with that is that it's taught more from the mindset of, there is this thing that we can't explain with classical physics, and it is explained by quantum mechanics. Whereas this year, these modules look more at this is how quantum mechanics works to explain these things. This is what an operator is. This is what the Schrödinger equation is. And our solutions to the Schrödinger equation are our quantum systems. We looked at applying quantum mechanics to different scenarios. For example, the not entirely realistic one-dimensional infinite well, and then the more realistic one-dimensional harmonic oscillators and three-dimensional harmonic oscillators. We looked at explaining the hydrogen atom electron and how that works. We looked at angular momentum being quantized and how that then would start to lead on to spin. The thing with quantum mechanics is that I love quantum mechanics, but I also hate quantum mechanics. I love the elegance of it. The fact that we can explain all this with a few equations and that it's a really interesting thing to do. It's also something that I find really difficult. It's one of those subjects that I love it, but I find it really hard. Now, the fact that I love it makes it easier to deal with the fact that it's hard. But if I don't come away from quantum mechanics with a sore head, then I know that I've not understood it. It's something I find quite infuriating, but also something that when it eventually clicks, which quantum does, it's something that is really rewarding. The module itself is actually a really nice module. It's taught at St Andrews by a lecturer called Dr. Antje Kuhnle, and she teaches really well. She's a bit fast, but that's okay. And she teaches it in a way that makes sense to me. Now, I learn quite well from lectures. I'm less of an academic reader. I don't learn that well from textbooks. I learn more from doing physics. So the methods that she uses are great. There's examples. We had workshops where we went through problems, and it's something that I think is really useful to be able to talk through physics with other people, whether it's with the lecturer, with a tutor, or with your peers, because I always find that talking through physics and doing physics is better. We also had this thing that was part of the module called Peerwise, where we were asked to author our own questions on quantum mechanics and to answer others. Now, this actually contributed to the overall grade, which it's something that I've only seen in these modules, these quantum mechanics modules, QM1 in this semester and QM2 that I'll talk about later. And it's actually really useful because it forces you to look critically at it and make sure you actually understand it. Or you just can't write a question. You have to be able to write a question, give the correct answer as a solution, but also give incorrect answers because they're multiple choice. And it's an exercise in looking at the physics and looking at where people would be tripped up by the physics. I wrote questions where I intentionally tried to trip people up with their understandings by maybe giving a red herring answer, one that looks right but is actually wrong, but then one that doesn't look quite right but is actually correct because it's just a different expression that means the same thing as the expression of the answer that they'd be looking for. It was a module that challenged me to learn in a slightly different way than I normally do, but eventually quantum mechanics clicked, for the most part. It was the module that actually, when I came out of the exam, I thought I'd done really well in. I was like, yes, I've got an 18 on the 20-point scale, which is like 80% in that exam. Like, I've got that. And I then came out with like 4 points lower than that. I got like a 14 or something. So it was one of those ones that I don't understand it entirely, and I don't think I ever will understand quantum mechanics entirely. I'm an astrophysicist, not a theoretical physicist. But it's a module that I really enjoyed doing, and I kind of wish I could take advanced quantum mechanics next year. I can't because of timetable clashes, but I kind of wish I could, and it's something that I think I will come back to in the future and spend time learning on my own. Moving on to the third module that I did in first semester, let's talk about maths for physicists. Now this is a module that everyone takes because maths is the language of physics. It's something that everyone needs to be able to use, or you can't do physics to later years. And up until this point, they've let the School of Maths teach the physicists how to do maths. And this is kind of the point at which they stop trying to let them give us good habits. We're taken back from the School of Maths and they start teaching us how to do maths like a physicist. So knowing where to draw the line on the infinite series, like yes, you only need to go to maybe second order. You don't really need to go any further than this. It makes no real difference to the outcome you get at the end. Yes, it might be mathematically better to go to sixth order, but we don't have time for that. It's a module that's taught by a lecturer at St Andrews who's widely regarded to be one of the best lecturers you will ever have in physics. A man called Dr. Chris Hooley. He's a bit mental, but in a really good way. He's a really good lecturer overall. And it was a bit of a shame that we were going through this in the COVID pandemic because apparently he sings in lectures. That being said, it was a really good module overall. We covered everything from density distributions through Fourier series and Fourier transforms, something that's really useful for solving complex problems because you can just turn them into a different basis, a different mathematical basis, which makes solving the problem so much easier, but you don't lose any of the physics. We went through vector calculus, div, grad, curl, all that stuff. Yes, that's the textbook name. And these are mathematical skills that are relied upon throughout the rest of physics, constantly. In fact, you look at some of these vector calculus things and they explain why lightning is attracted to pointy metal rather than just a metal sheet. And it's really interesting. We went through vector calculus not only in your normal Cartesian coordinates, your x, y, and z, but also through different coordinate systems, through cylindrical coordinate systems, through spherical polar coordinate systems. Something that is really important when you're looking at different problems in physics. Because trying to do gravity in x, y, and z just is a nightmare. Doing it in spherical coordinates, that makes a bit more sense. It's a radial force. That was really interesting to do, and I actually really enjoyed that module. In my notes for recording this video, I've just kind of written, this was the most satisfying module of the semester. Because it was. I really enjoyed it, and I want to go back and look through the stuff a bit more in depth, really understand it, and I'd quite like to do some of that this summer before heading into the next academic year, because yes, I understood it enough to use it, but I want to actually understand what's going on and really solidify my understanding. This brings us to the fourth module from first semester. And this one is one I've complained about a bit on the channel before, and I'm going to complain about it again. It's a module called Computational Physics. Now, computational physics as an area of physics is very important. We need to be able to use computers to do things because, quite frankly, going through everything with pen and paper is slow and you're likely to make more mistakes. We need computers to deal with vast data sets. But this module, jeez, I'm still angry about it. The problem with the module, there were quite a lot of problems with this module. Some of them will be fixed for next year. Some of them, I have less hope, but I'll come on to how that's still my problem next year. So this module goes through using a computational language to answer physics problems, to model things, to explain things, to create plots, and all that sort of thing. We used a programming language called Mathematica for it. It's made by Wolfram, it's proprietary, and I don't like it. I still, to this day, do not understand how some of my code works. I don't understand why some of my lines are more brackets than anything else, and I just don't like it as a language. I found it really hard to understand how to use it. I found the module to be just not great overall. There was continuous assessment every week on the stuff we were learning in that week, and we were learning remotely. We couldn't really easily ask for help. It was a stressful module. It was a module with an exam that was coding, and I'm sorry, those are just, why? Coding exams are stupid. Like, give me a computational project, fine. The problem with a coding exam is it gives you a time limit to find the bug, and sometimes that time is not enough, especially if you find that bug in the last half hour. Now, on the whole, I did pretty well in this module, but I'm not entirely sure how, because I didn't understand most of what I was doing. I probably would not have done as well if that module had not, if the exams from that semester had not been open book. Next year, I'm really glad it's moving to Python, because Python is free. Python has a massive library of resources online where people have had problems and there are solutions. And that makes it so much easier. And more importantly, Python is used more. Python is used in a massive array of use cases across society and in physics. It's used for data analysis. It's Python we use in extragalactic astronomy. It's Python that we're taught in the first year and second year astrolabs. It's Python that is used in observational astronomy. And it's a really useful language. It might not be a master of anything, but it's a jack of all trades. And I kind of wish I was better at using it, to be honest. But I'm glad that that module will be going to Python next year. That module was kind of the bane of my existence for the entirety of the semester. I'm glad I passed it and don't have to resit it or anything. And overall, it was probably the most irritating thing about first semester. Sorry if I've just ranted about that. I needed to get that off my chest. So I said I'd talk about transferable skills later, so I'm not going to talk about that now. I'm now going to talk a bit about the areas of first semester that I've termed as academic-ish. And when I say academic-ish, I mean the things that I do in the School of Physics that aren't related to a module grade. So one of the systems that exists in the school, and actually in the university as a whole, is the class rep system. This is an academic representation system where somebody is elected from each cohort of students to be their representative to the school on what we call the Student Staff Council. In other schools in St Andrews, it's called the Student Staff Consultative Committee, which is really hard to say, and I like Student Staff Council, or SSC, a lot better. This is something that I tried to become in my first year and was unsuccessful. It's something that I didn't bother with in second year because I was a bit busy and I didn't really want the job. And then in third year, I thought, no, I want this job. I want to be the class rep for third year astrophysics. And I ran for it. I ran on a platform of really just, I don't even remember what I really ran on. Mostly just trying to be a representative for everyone, not just for myself. And I put forward that I had the experience. I'd been a society committee member for 2 years. I'd been the treasurer for University Hall, the Hall committee, in my second year. And I won. I won third year Astro class rep. I also took on the role of careers rep in the school. I was then later asked to become a school ambassador, which isn't something that is part of the class rep system, it's separate, but I'm going to talk about it a little as well. The class rep system is something that a lot of people have lost faith in recent years, but I never did. I think class reps have a role to play that is quite often not fully realised by a lot of people. I'm not sure that I don't think that people realise quite how much work class reps can and do. What we do as class reps is we go and we try to solve all of the problems that come up in a module. When there's a class test that's coming that people don't feel prepared for, when there's people needing notes that aren't accessible, when there's a problem that somebody's having that just isn't being solved, they come to a class rep and the class rep takes that further up the chain, be it to the school president, to the module coordinator, to the director of teaching if need be. Rarely director of teaching. It's something that I've really enjoyed doing, and from the class rep system we have these expansion roles, these extra things you can do. For me, that was being the school's careers rep. Now, careers, and more accurately careers and skills, is something that I think is really important. We have this module called Transferable Skills for Physicists, which tries to teach us some of the skills we need for going into the workplace. But there are other aspects of careers and skills that people don't really get to experience. There's this endless barrage of finance and banking and tech recruiting in physics departments, because these are the companies that have the money for these big recruitment drives. This is something I don't particularly like. This is something that a lot of people don't particularly like. So I wanted to work with the school president to get this wider array of careers events. I worked with the Physics Society to put on a skills event where we taught LaTeX to people. Now it's a formatting language, a word processing language. I've actually made a video about it, so go check it out, top right hand corner. It's a really long video, it's a nice tutorial about how to get started in LaTeX. This was something I started to find really rewarding. I was really glad I ran for it. It started to help me grow as a person, become more comfortable talking to people, more comfortable giving my opinion on things. with the objective of making positive change, which I did. I made this positive change. For example, I was part of the group of students who were all pushing for Mathematica to go from Compphys and to be replaced with Python, which we managed. It got done. I'll talk a bit more about class rep stuff later, and more accurately careers rep a bit later on. I also was a school ambassador, like I said, and I still am a school ambassador. We're students that are asked to come along to open days, visiting days, whatever you want to call them, and answer questions that prospective students have. We answer them from our own perspective, we're not told what to say, and again, it was something that helped me really come out of my shell and become more comfortable talking to people, more comfortable talking to a camera as well, because it was all online. I was talking to the webcam behind my head, and I think it's really helped me on YouTube as well, but that's a separate topic for a future video coming in a few weeks. That's kind of everything along the academic-ish side of first semester, so let's talk social. And this is where I'm going to talk a wee bit more about COVID. The social side of university in first semester was a bit stinted, but not as stinted as it was later. So we had online Gaelic classes for Celtic Society, we had no dance classes, and as much as I really miss dancing, I've missed a lot of the social side. I couldn't go to the pub with people for a long time. I haven't had a party in months because they're just not allowed, and it was a bit tough. Especially considering that the School of Physics and Astronomy has this brilliant community, and that I'm used to learning with a great group of people, and I couldn't do that. It got worse in second semester. I will talk a bit more about that later. I will give a bit more context for all that. And yeah, it was a bit tough, but we got through it. We found our way around it. We spent a lot of time on Zoom. I really want to uninstall Zoom. So that's everything on first semester that I have to say. So let's go on to second. This is from January to May. The problem we had is that at Christmas time, we had this massive lockdown. Everything got shut down because there was a massive rise in the Kent variant, the UK variant, whatever the hell it's called now, Alpha variant maybe? I can't remember what it's called. This affected university. Everything went online. Lectures already were, but tutorials now, all online. Workshops, all online. Social side, all online for months. We went into the hardest lockdown that we'd had, and it was brutal. It was a really hard time, but as I've said, I'm stubborn. Wasn't going to let it stop me with my academics. So, what modules did I do in second semester? We had Computational Astrophysics. We had Quantum Mechanics 2. We had Electromagnetism, and we had Thermal and Statistical Physics. Now, these modules, again, I enjoyed some of them more than others. In fact, I really enjoyed one of them, and the others were fine. One was pretty hard. But on the whole, I had one module that I really loved, and that was Computational Astrophysics. Again, this is a computational module, but it was way better than Compphys. I was really glad that I could be really positive about this one, despite being really negative about the other. Computational astrophysics was completely different to computational physics. Instead of using computational programming to answer problems of like pendulums and waves and stuff, we were using computational tools, computational programming, to solve numerical simulation problems, numerical integration problems. And that was really fun. We were introduced to an entirely new language, one called Fortran 90 specifically. It's a computational language that is compiled, it is so much faster, and it's really meticulous in how you have to format things. So in Python, you can just declare a variable. You can just, I need a new variable, we'll just call it alpha or something like that. In Fortran, you have to declare your variables at the top, whether they're an integer or a real number. You have to declare the precision that your real numbers are given to. And it's a very different way of coding, and one that I find brilliant. My problem with Python has always been that while I can use it, I don't understand what the computer is doing, the mathematical operations that the computer is going through to do things. With Fortran, I know what the computer is doing because I'm having to tell it specifically what to do, and I find that really great. I love that method of programming. I like low-level languages like this. We used it for a vast array of things, culminating in doing gravitational simulations, simulating a solar system, a gravitational system, which is a numerical integration system, and we had to try and find a stable orbital system It was really, really good. I loved doing that project. It was entirely coursework based. There was no exam, because why would you have coding exams? I ask this again. But we didn't have coding exams for it, and I'm really glad that we got the opportunity to do this. It was really fun. As a module, I think it was my best grade. It was my best grade or my second best grade for the semester. And it's formed the basis of the project that I'm doing right now, the summer research project into supernovae. There are vlogs appearing on my channel at the minute that you can go and watch if you would like to see me struggle with coding and have a lot of fun messing around with supernova simulations. It was a module that I think was undersold. Some people don't like coding in Fortran, some people don't like low-level languages. It's a module that isn't sold particularly well by a lot of people. But if you're like me and you really like coding in this way, it's brilliant, and it's been my favourite module that I've done at university so far, by a country mile. I'm kind of going to miss the module, but at the same time, it's really shown me what I want to be doing. So, on the one hand, I'm sad it's over. On the other hand, I'm really glad that I get to use these skills now. Having spoken a bit about that really brilliant module, let's go on to another one I really enjoyed, Quantum Mechanics 2. This leads on from Quantum Mechanics 1 in first year, same lecturer, and largely the same format, so I won't go on and on about that. Through this module, we went through more in-depth quantum mechanics, more interesting quantum mechanics, looking at how quantum mechanics allows us to explain some different things. We looked at perturbation theory using simple quantum mechanical methods that we looked at in first semester, and using them to essentially use superimposing things together to explain more complex problems. We looked at spin, particle spin, this intrinsic angular momentum that particles have and the effects that that has. It was a really interesting module that I'm not going to talk too much about because a lot of it is very similar to Quantum Mechanics 1. And it then will let me talk a little bit more about thermal and statistical physics, the third module I'm going to talk about that we did in semester 2. This is a kind of hybrid module. We started with the statistical side of it, which looks at things individually, particles individually on their own. We look at baryons and fermions, the two different types of particles that you can have, and how they behave at really low temperatures. We looked at how the quantum mechanical spins determine that a fermion can't occupy the same quantum state as another one, something called the Pauli exclusion principle. I really enjoyed statistical physics. The other half of this module is thermal physics, and this is something that I did not enjoy quite as much. It's gas laws, it's entropy, and I don't like that it's the macroscopic, the big universe measurable side of entropy rather than the small statistical quantized versions and that sort of thing. I like that side. I didn't like the thermal side as much. I found that much more challenging to understand, and it's not something that I really wrapped my head around. I'd like to go back and try and understand it more. I probably will, but it's not something that clicked with me immediately. The module as a whole was very well run. We had workshops again in this module that I've said before, I really like these workshops, being able to sit and talk with people, even through Teams, and actually talk through physics. It was also the module that got me to do a lot more group work. Some of my friends found the same way that I do, that this module really works well if you can talk through it with people and reason it out with other people out loud, because sometimes mathematically it can be more confusing than talking through it and then applying the maths. So that was a really fun time to do it. I got to spend time on Teams and then later a little bit in person, socially distanced of course, talking with friends about this and trying to understand it, and it was really good fun. And now, finally, the fourth module that was at semester 2 only, electromagnetism. Actually, I think my best, if not my second best grade for this semester, but also the module that I thought I was going to fail. It was a very pleasant surprise when it came through and I'd done really well in it. Electromagnetism is one of the core things you need to understand in physics. It's one of those things that it's infuriating when you don't get it and you can go through a lot of the module and not understand what's going on. You look at electrostatics, so electric fields around particles that aren't moving, charges that aren't moving. You look at magnetostatics, again, magnetic fields around magnets that aren't moving, and then you start looking a little bit more at electrodynamics and magnetodynamics. So you've got moving fields, moving forces, changing fields. You look at electromagnetic radiation, light. the combination of this electrostatics and electrodynamics and magnetostatics, magnetodynamics, and it's really cool, but it's also quite challenging. I still struggle working out what things I should be using, which of Maxwell's equations, these really elegant equations that explain electromagnetism. There's only like 4 of them, and they explain just about everything. The thing is, I find it tricky. It's mathematically quite challenging at times, and I'm not really sure that I ever truly got it. I kind of figured out how to answer the questions, and I actually think I'd need to go back and really spend time understanding the physics. Take like a month and actually work on electromagnetism and spend time really looking at it. I don't know when I'll get to that, but it's something I want to do. This is kind of becoming a recurring theme that I've got through the year and I've got a decent understanding, but I want a better understanding because I get a kick out of learning. And I'm going to talk about this in later videos about how much I enjoy learning. So make sure you subscribe and hit the bell icon for that. So that covers the academics of second semester, and we should then maybe talk about the social side. As I said, we were under really tight lockdown for a really long time. Like half the semester was a hard lockdown. Even when it started to lift a bit and it was a slightly less hard but still pretty hard lockdown, we had a minor flare-up in St Andrews that led to a voluntary lockdown being requested of us. As a university community, we decided to protect ourselves, protect each other, and lock down for a bit to let cases be found, let the people who had been infected with coronavirus get isolated, and then we got to have a bit more freedom again. Throughout the semester, we had entirely online socials, so it was socials in the school were all online, socials in societies were all online. We were all getting a bit sick of Zoom pub quizzes, if I'm quite honest. We couldn't do anything about it, but we made the best of the situation. Am I looking forward to things going back to normal next year? A bit? Yeah, definitely. And I know I've been saying back to normal a bit soon for about a year now, but it finally looks like there's light at the end of the tunnel. I want to get back out on a dance floor and have a ceilidh, do some Scottish country dancing. Yes, those are different. I want to go to the observing nights at the observatory with Astrosoc. I want to play in a wind band again, because I really miss it. I barely used my horn for the last year. I miss it all and I want it back. And it's probably been one of the toughest things this year that we had this massive limitation on what we could do. So that covers the social side and my sort of lamenting for the past and hoping for the future. What about the academic-ish stuff? So I said I'd talk a bit more about Careers Rep, and I will. I put on an event early in the second semester, which was about science communication. So I said that I wanted to provide a wider range of events for people, and science communication is not something that was ever really talked about in previous events. So I decided, since we are in a pandemic and people don't have to travel to give talks, they can just give them through Teams, that I would get in touch with Dr. Simon Clark, YouTube science communicator, Twitch science communicator, and ask him, would he do a talk about what it's like to be a science communicator and why you should consider doing it? And he said, yeah. So I got Simon to come and do a talk on Teams talking about his job as a science communicator and why it's worth doing, why someone should consider doing it and what it's like to do it. And it was really good. It was a really well attended event and I'm really happy with how it came out. And that wasn't the only academic-ish thing that I did in second semester. I also ran for election. Not as a class rep, but as school president. Now, the school president is the primary academic representative for the entire school. They are the link between the students and the staff and with the wider university. And I ran for election. Now, initially I had an opponent, but they dropped out, but I still had to beat reopen nominations. I had to convince people that I was better than asking for someone else to do the job. So I got elected. That kind of covers second semester. So let's talk about the module I've been sort of teasing throughout the entire video, which is transferable skills for physicists, also known as Let's Teach Physicists to Function in Society. Now, it's a full year module, so it runs from September to May, and it's widely regarded as one of the best modules in the physics and astronomy degrees at St Andrews. It's very different from all of your other modules because you're not being specifically taught physics. You're being taught how to be a scientist that does more than just learn. We do a wide variety of tasks. There are 6 main tasks in the module. The first one we got told to do was to compare two academic papers. We were given one longer paper full of the full methods of everything and the analyses and how all that was done. And then we were given a letters paper, a shorter one that is essentially an announcement of, we did this, we have done this thing, we have discovered this thing, and we think you should know about it. And we were asked to compare these, look at what the point of these papers were, why they chose the journals they chose to publish in. And it was really interesting to academically critique a paper. We were then told that we had to give a brief talk on a subject of our choice. Now, there was a nice long list of things that you could give talks on, or if you wanted, you could come up with your own. Now, I looked down the list and I didn't like any of the topics particularly much. But given it was only a 10-minute talk, so it could be fairly loosely scientific. Like, you had to go into the science a bit, but not in depth. Like, you're not giving a lecture. So I decided that I wanted to talk about Cassini, the space probe that visited Saturn. In fact, you might be remembering, if you've watched the channel for a while, that I made a video about that. I turned that talk into a video. It's up in the top right hand corner. And it was really interesting to go and explore a topic that I was interested in, that no one told me to go and do, that was entirely mine. To go and read the papers, to go and read the articles, to listen to people talk about Cassini, and to discover loads of things about it. It was a really fun talk to give as well, because it had been essentially my academic baby, I guess, for about 3 weeks, and it was really exciting. After that, we were then asked to write a review article on a different topic, a topic chosen by the school, well, suggested by the school. The academics in the School of Physics and Astronomy came up with a nice long list of topics you could write a review article about. Now, a review article is when you have an article written that covers all of the research in a field, or the important research in a field, and distills it down into one paper. We were asked to do that. Now, the person who suggested your topic was somebody you could then go and talk to about it, which was brilliant. I got to go and talk to an academic in the school who had suggested my topic, galactic center star formation. I got to write a really long paper about it, and it was not perfect, but it was pretty good. I made a couple of small mistakes that I missed on the proofread, but it's fine. And for the most part, I got feedback that it was saying it was a good article, and I really enjoyed it. It was a similar process to when I make videos for this channel, science videos I mean, where I go and I research and then I distill that down into the important things, and then I turn it into a video in this case, but for that it was an article. From that article, we then went on to do a talk for a conference that is essentially all of the people in the year who are doing the module give talks and get asked questions. And yes, it counts for your module grade, but it's really fun. And I learned loads about a wide array of physics that I had never studied before, but other people had gone away and studied, and they'd learned the physics for it. So I gave my talk on my star formation around the galactic center, which is around a supermassive black hole. It's stars forming around a black hole, it's cool. I really need to make a video about that. That's on my list of things to do. And that was an amazing experience. It would have been so much better if we'd done it in person though, because normally you go up to this nice big house near Dundee and it would have been really fun to do it in person. I'm kind of sad that we didn't, but again, COVID. It took so much away. Finally, we went on to a group project, and it was to write a proposal. The proposal could be for anything. You could do a lab proposal, like for a lab experiment for a teaching lab, or you could do what we did, which was to write a telescope proposal asking for telescope time to observe exoplanet transits to try and determine if a planet candidate is actually a planet, or you could put in a research proposal for some new research. That's the hardest one. I don't know if anyone did that. We didn't do that because it was just that bit more effort, and we're all astronomers and we could do the telescope proposal. But it was really good to work as a team. So we didn't all do a proposal, we each did a part of it. So I worked predominantly with another guy in the group, and we worked on the coding side of it to work out when would be a good time to observe this, whether it would be observable for long enough, all that sort of thing. We had two people that were working on the presentation, we had someone work on writing the proposal document, and it was a really nice group to be a part of. I really lucked out with that group, and it did help that we'd been in the same group, or same skills tutorial, for the better part of a year by that point, and we'd got to know each other. There wasn't the, right, you're working together, and then all the awkwardness that normally ensues at that point. Overall, that module was so much fun. It was something totally different. It's something that I think really played into what I'm doing on YouTube. It made me more confident talking. It gave me more scope to really explore things. It gave me a video to make with a Cassini talk. I really enjoyed my time with it. Now looking again at the whole year, we're on the whole year part now. Would I do third year again in this way? Probably not. Do I like that we had open book exams? Yeah, I do. I kind of wish we could keep them. But would I do all of this again? Or would I rather have it in person? I'd rather have it in person. But if you want to listen to me talk about university in person versus online, subscribe, hit the bell icon. I'm going to be talking about that soon. Overall, this year's been pretty good. I'm averaging a first in the degree, so that's good. I'm not averaging it by much, but I'm averaging it. And I'm really glad that I got involved with things. I'm glad I got involved with class rep, as careers rep. I'm glad I became a school ambassador. I'm glad I ran for election as school president. I'm glad we have transferable skills for physicists. I'm glad I got to study comp astro, because now I'm doing a project based on the skills I learned there, and I'm having so much fun. And I'm glad I have another 2 years, because this is the year that, although it's been hard, we've done actual science. Not just learning the core stuff that everyone has to learn, but actually developing the skills properly to be a scientist. I have 2 more years. I have my 4th year, my senior honours year, and then my 5th year, my MPhys year. I'm going to be studying a wide array of really interesting topics. In fact, there are more that I want to do than I can actually do, and I cannot wait. I've got another 2 months before I get back to learning in university teaching schedules, but I'm really looking forward to it. So this has been my 3rd year in review. If you are new and you have enjoyed this, please do like and then subscribe. Hit the bell icon. I've got some really interesting videos coming that I think you'll enjoy. So stay tuned for all those. In the meantime though, I've been Thomas Rintoul. I have finished my 3rd year at the University of St Andrews. I cannot wait for the 4th one to start. And I will see you in my next video. See ya.